a series of 6 on databases. The topic of this module is Advanced SQL. In the last module, we talked about the basics of SQL syntax that you use to talk to relational databases. We went through select and joins aggregate functions. We talked about creating databases and tables, showing and describing tables and databases that are available, how to insert data both from an individual row and also from a bulk perspective, and then updating and deleting. So those form the basic operations that you need to use to know to use a relational database. This time, in this module, we are talking more about some of the advanced features. First one is what if I want to alter the structure of a table that I've already created. It may be that this is simple enough just to delete the whole thing and create a new table and reload it with the data, but it may be that I've done a lot of operations on this table already, or that there's a lot of data in it, and therefore it's simpler to alter the table. The syntax for this is the alter SQL command. Alter table, table name, and then the operations you want to make to change the table. Let's say that I want to add a column called B magnitude to my star table that we introduced last time, and I want to put it after my V magnitude. That's the purpose of this first command there. So I'd alter table star, add column, the column that I'm adding, B magnitude, the data type of that column, a double in this case, and I'm adding it after the V magnitude. If I want to remove that B magnitude column at a later date, then I can do it simply by doing alter table star drop column and then the column name. There are other operations that I can do with the alter table, changing names, changing data types, that sort of thing. You can look those up. Now, often when you're working with a table, there's a particular operation that you're going to be doing on a table that is repetitive, a particular type of query, particular query for a certain subset of it that you're going to use, and you could put that information into a separate table, but one thing you can do with a relational database is what's called create a view, which is a specification of a subset of a table or set of tables which you're going to treat as a table in its own right, but you don't want to go through all the hassle of creating that as a table in its own right, because it may be that that's repeating data. You don't necessarily need to do that. So a view is very useful, and for that context, the syntax is create view and the view name as, and then you specify a select statement which defines the data that is associated with that view. So let's say there's a particular region of sky which I'm going to be using for a lot of operations, and I can define that as a view through select star from star, where I then define the positional constraints defining that region. I can then do a regular select statement, and instead of using the table name, I can use the name of my view, in this case region 1 view, as the table, and it will only use the data that is defined by that particular view, so it will use the data within the positional constraints on the sky that I've defined as the first data set that it's working on, and then apply the additional constraints that I'm using in the where statement in my select statement. Similarly, I can create a view as the result of an inner join in this particular case with more information, and because I've specified that inner join, there will be those column names in the view. That inner join will look as though it's a table to all intents and purposes, and I can query it as if it were a table in its own right, even though from a programmatic perspective it's being created on the fly by the relational database. So views can be incredibly powerful ways of making your life more manageable. Next, indexes. When you're working with a database and you're doing querying, sometimes the performance can be very slow. This can be because of the way that the data is arranged on the disk. And ways around this are to create specific lookup tables to allow fast access, or specific lookup data structures to allow fast access for data. Syntax for this is create index name on a table name and the columns that you're using in that. So it may be that I'm going to be running a number of queries against the V magnitude column in my table, and I'm finding that they're being particularly slow. I would hope that by creating an index on them, any queries running against that will actually be faster. There are two types of queries two types of indexes that you can have on a table. You have what's called a clustered index, first of all, and this is one in which the ordering of data entries is actually the same as the ordering of the data records as they are physically put onto disk. I've already said in the previous talks that if you have a primary key on a table, that is automatically a clustered index. Since there can only be one clustered index per table, if you already have a primary key on your table, any other indexes you create on that table will be unclustered and will make use, therefore, of specific structures in the relational database for doing their lookup. However, you can have multiple unclustered indexes on the same table. They're typically implemented as B+ trees, which are a very efficient data lookup structure, but there are alternate types for implementation depending on the type of data that you're working with and the relational database system that you're using. It may be that there is a collection of operations that I'm constructing, that I'm carrying out on my database table, that I'm going to be repeating a number of times. And in the same way that if I was doing this programmatically, I might actually write this up as a function. In the database world, you can write this as a stored procedure. It is the set of operations that you're going to collect, the set of select statements and joins and such that you're going to work to give you the answer that you want for a particular operation. Syntax is create procedure, the procedure name, and then the parameters the procedure can take, the arguments of the function, and then the declaration of what is required. In this particular case, the example given here, I'm creating a procedure called find nearest neighbor to a star, where I'm going to just take that as the name. I'm assuming that there is already an existing function in my database, an existing procedure, which will give me the nearest neighbor given a position on the sky. In writing this procedure, the idea is that the procedure will do a lookup to get the position of the star name I've given and then pass the position information to the existing procedure and return the result of that. So what I first of all do is create procedure, name of the procedure, the argument. It's going to be the type of the argument is varchar, a variable character of up to length 20. And then I declare the internal parameters for this procedure. Those are denoted by the @ sign. I'm declaring an array and a dec variable. These are of type float. I'm declaring a name variable that's of varchar 20. And then I say select, and then I set the RA variable to the value of the RA column, the dec variable to the value of the dec column from my table star, where the name column is like the star name that I've given as the argument to my procedure, and then I select name from get nearest neighbor with the array_dec and end. And then to execute this, I use the exec statement, exec find nearest neighbor, Sirius in quotes, and that would then give me the nearest neighbor star, the name of the nearest neighbor star to Sirius in my database. Cursors are a way of actually physically doing going through a table, doing an operation on a table one row at a time. And there is a particular set of syntax for them. The next slide we will give an example of exactly how to do that. It has to be said, though, that cursors are the slowest way of accessing data in a relational database. This operation of physically going through one row at a time in a table is very inefficient and not utilizing the join power of the database, the relational database. But sometimes it's necessary for the type of operation that you want to do, that you want to make use of this sort of functionality. In this particular case, for each row in our data set, our scenarios, we want to update a particular stellar model that we have that exists elsewhere. For some reason, we can't do this as the result of a join. So syntax is, we first of all declare a number of variables. We declare a name variable and the data type on that, varchar20. We declare a magnitude variable, and it's of the float data type. And then we declare our cursor. This is the thing that's going to go through each row. We say it's called star cursor. And then we say what it does is it selects the name and the average V magnitude from our table star when I'm grouping by stellar type. So that's going to give me those two pieces of information for my star table. And then I open my star cursor. What I say is that I fetch into my cursor that information in the name and the magnitude, and then I have some stored procedure already called update stellar model, and that I'm going to run that based on the values of the name and the magnitude that I've loaded from running my cursor on my particular operations. So in this particular way, I'm going to be going through the different types of stellar type that I have in my star table. I'm getting their average magnitudes and the name of that type of stellar type, and I'm updating my stellar model with the values of those average V magnitudes. Triggers are a way of having particular operations in the database happen depending on other things that you've done. So it may be that if I insert data into one table, there's another table which needs to be updated, or if I update data in one table, an operation has to be performed on another table, or if I delete data, another operation has to be done. So in the syntax here, I'm creating a trigger called star trigger on my table star for an update, saying that if the V magnitude column is updated in any way through an update statement, then I would execute this a stored procedure that I've called refresh models, which would presumably do something to other tables on the basis of that information that I've updated. So other operations in the database are triggered by an operation I've created on that table. Finally, I'll give an example of how you can work with a relational database from a programmatic perspective. A lot of relational databases have web-based interfaces or command line-based interfaces for you to specifically type SQL statements in, but often it's very useful to actually be able to access the database through an interface layer so that you can write code to do it. And this little code snippet here is an example of how to do that with Python. So there's a particular Python module in this code called MySQLDB, which I'm importing, and then I specify the connection details for my code to be able to connect to a database server somewhere which is listening on a particular port. I give it my username for the relational database that I'm accessing, my password, and the name of the database that I'm accessing. I then construct a cursor. In this particular case, this is just the data structure that is defined in the MySQL statement. It's not a database cursor. I then define the SQL statement. In this case, I just wanted to return everything from my table star. I execute that. So the Python code sends the appropriate SQL command over the wire to the database, and the information is piped back. And then I can fetch all the results, or I could fetch the results one at a time, or do all manner of operations to retrieve the data and work with it appropriately. And those are specified in the MySQLDB documentation. But there you have an example of how you can access a relational base programmatically, making use of your SQL, but you're not using the interface that's been provided by the DBMS. You're doing it through a standard programmatic interface. And such interfaces, such modules, are defined for any manner of computer languages and most databases. And that is the end of this module.